Thank you very much. Appreciate everybody coming for, what in hindsight is probably the least exciting topic title ever. So we'll try to make that up with some material. Why I want to be here today is, I've been doing security for quite a while. And I have the fortune of going to a lot of conferences and seeing a lot of really great talks. And for me, the greatest talks are not the ones where they always just drop the tool and they do the demo. I like learning the story about how someone got there, because I think there's often the tendency to think, well, that person's just naturally a genius. And, there are natural geniuses, and there are people like me who just Google for everything constantly and try to make something work. So I think, I hope that there's a value in there in the storytelling. And I want to share a couple key points about, what I consider, to be good usability, good security. We're going to talk a lot about, some tools. There's tons of live demos. So, that always goes very well, never has a problem. So I think we'll be the same here. And you'll see QR codes up. If you want to scan the QR codes, it's fine. They're not connected to anything. They're demo codes. You could play around with the Quest Defender soft token, or you could play around with Google Authenticator if you like. So how is it that I come to be here today? Principally because of a piece of software that is just absolutely, I would say, unusable, especially for non-security people. It's called the Dell, formerly Dell, now Quest One Identity Defender product. It's a one-time password system, that has obviously a GUI, a way to present, a one-time password for multi-factor authentication. And it has a series of back-end hooks, so you can easily add OTP, a multi-factor auth to, let's say, VPN, or let's say system login. And it has some nice enterprise-y type features. They support a whole bunch of tokens. They support their own Bizarro token that has a grid on it, and you have to select stuff. They support SMS token messages. They support YubiKey and what it looks to be Vasco rebranded tokens. So they have a whole range of token support. And they also support software-based tokens, right? These are tokens that work on Android, that work on iOS, they work in Windows, Java, even BlackBerry and Windows Mobile. So, and that is really the scope of the talk today that I want to share with you. Not really interested in the background infrastructure today, not really interested in hardware tokens or custom tokens. I'm only focusing on the software-based token. The principal reason why I'm focusing on the software-based token is because this has caused me the most pain, right? So if you can imagine you're an organization and you release, you get a new employee, you give them a laptop, maybe you pay for their phone, and you say, that's great, go ahead and VPN into the network. We're just going to need you to sign up for multi-factor authentication. And you might have worked somewhere where they did that well, and that seemed okay to you, until you received this email that said, download the app and enter approximately 110 characters on your phone with no error correction or indication that you have it right until you press the activate button, and then it either tells you your token code is invalid or not. It's, if you remember playing Mastermind, where you had like 6 digits and you had to figure out which is the digit. Well, now you have 110. So horrible, horrible, horrible. And I said, I'm new here, but I think I can help you, right? So we went to make QR codes because the Android version of Dell Quest Defender soft token actually supports the ability to scan QR codes. So that's great. So let's scan the QR code. If we select scan QR code, unfortunately, the token app does not actually build the barcode scanner into it. They tell you, go to the Google Play Store and download barcode scanner and install that yourself. That's great usability. And then when you do so, you realize that in order to activate multi-factor authentication, you are now giving a fourth party access to all of your contacts, all of your Wi-Fi connection information, because that's a critical component of, barcodes apparently. So that doesn't seem right, and so that on its surface would warrant further inspection, further modification. So if we switch to iOS, unfortunately the story is even worse, because in iOS you're presented with the same crippling usability. You know, you've got to enter in these characters, you've got to hit done, and they don't tell you that you have an option to scan, right? So, you know, the world's flagship phone ecosystem, you know, with a 12 megapixel camera is not able to help you import your multi-factor authentication token. You must use a third-party QR reader that you find by yourself. You have to create a QR code. You have to then scan it. You have to extract the activation code by using copy and paste, which is universally so easy on mobility devices, and then paste it into the software token, you know, which strikes me circa 2001, right? It's just not acceptable nowadays we can't treat people this way from a security perspective. It's not right, and you know, it gives security, I think, a bad name when you're just trying to protect accountants and people in marketing and people in sales, and you're making them go through these hoops. I mean, if the hoops are bad enough that people who are in the information security field, who understand the value of multi-factor authentication, who know what a one-time password is, know the value that it protects, and then still choose to like hate a system like this, that's a bad sign. So what I wanted to look at is, hey, there already exists a very usable one-time password token keeper. It's called Google Authenticator. Let's look at the token that is generated by the software token app, and let's figure out if is there an opportunity here? Is there a compatibility between the data, the essence of these proprietary software tokens in being used in Google Authenticator? So I'm going to say we're going to perform, you know, what I call, you know, a little bit of deductive reasoning in airplane mode, which means if I turn on airplane mode and the phones have no network connectivity whatsoever, I'm still able to import the token, and I'm still able to generate valid one-time passwords, valid 6-digit tokens. So that tells me that these strings of all lowercase characters through A through Z, they must contain the token serial number, because you can see the serial number in both instances, right? And that's not made up somewhere else. And it must contain the data to generate the one-time password. We would generally have to stop there, but they were also nice enough to tell you that the token type is oath compliant SHA-1. When I say something like, and of course we know, or I say something that sounds obvious, what I'm omitting in parentheses is I Googled for this, okay? So, of course, oath-compliant SHA-1 tokens are an RFC 4226 standard related to kind of HMAC one-time passwords, right? Which is an easy thing to Google for. So I've got a lot of hope, you know, when I'm starting this adventure. I know that whatever the activation code is has enough information to generate a one-time password. And I believe that the one-time password is going to be compatible and compliant with an industry standard, which Google Authenticator also agrees to adhere by. So I think I have a syllogism here, right? A equals B, B equals C, A equals C. So I think I'm good. And my goal for the rest of this talk is to turn that phrase of text characters into a QR code so that it can be loaded in Google Authenticator and I can throw away the old code. So in order to do that, I'm going to want to reverse engineer the application. Well, it's an Android application. So what you're looking at is a screenshot of a console accessing a rooted Android device, right? That is like a big Google search there. How do I root my device? How do I get access to log data? Where does system store information? I mean, each one of these is valuable Google searching. So I run this command adb logcat, it dumps the log, and I grep for the word token. Because if I'm really, really lucky, they really, really instrumented a lot of logging. And that would be ideal, right, from a researcher perspective, if they said, hey, this is your activation code, this is what we think it is, and blah, blah, blah. So unfortunately, they don't do any of that. So that's not of value to me. So my next step is to look at an Android decompiler. So if I copy the APK file, right, which is the, well, what is it? It is the Java archive data file. So it's a jar file. It came from the end device. And I know that, and remember, I know that means what? I Googled that APK files and jar files are zip files, so I'm going to unzip it. And now I've got a DEX file. Okay, what is a DEX file? Well, a DEX file is a Dalvik DEX file, right? Okay, very good, very good. So now I do some more Googling, I say, I'm going to dump this. So I want to convert this because if I try to edit this file, it's binary, it's not really usable for me. So I'm going to look at that. I'll call it output.jar. Then I'm going to unzip output.jar. And great, it gave me, a bunch of text files that should be the decompiled code. So that's our, this is a very exciting day, and I'm thrilled to be doing this. And let's just look at dump.txt. But unfortunately, and I, didn't go to programmer school by trade, this is not the easiest piece of code to digest, right? A lot of labels that are just, random letters and numbers for variable definition. It's not really go-to statements. I don't see my common, I don't see a lot of parentheses. This is not code that I, not a smart but very lazy man, am interested in working with. So I'm like, I'm out, okay? So then the next thing I do is I say, well, hey, I could use Ollie debug because Dell Quest, they make available the Windows version of the Java token. That's fantastic. Ollie debug, I hear, is this great disassembler, lets you look at all the code. That proves even a worse idea for the lazy and unsmart, okay? So we looked at it, I looked at it, there was threads involved, there was not common naming constructions, and I was like, nah, I'm not gonna do that. So I just move on, right? That's a process for me, is to try something. When it's too hard, move on to something else. And when that's too hard, go back to the first thing and say, hey, can I make this thing work? And so they also make a generic Java app. So I say, okay, there's a generic Java app. Java Snoop, Java token. And that is a jar file, which we know is zippable, so we unzip it. And it puts it in the same kind of space, so I'm going to go to Dell Quest token DT. All right, and these are class files, and I know that if I look at class files, my eyes go cross-eyed because they're not readable. So I remember a long time ago, I used this thing called Java Decompiler. So I'm going to run it. I'm going to run it on the same file so we can kind of compare apples to apples. And it makes this .jad file. All right, well, okay. Hey, this is pretty usable, right? So I've got function names that I can understand, right? So debug probably makes something go out, Hex dump, that probably dumps hex code. So I'm like, I'm going to fixate on this code for the rest of the exercise. Okay, so now I'm here. What I want to do is figure out where in the code is the activation code being processed, right? I could read all of the code, find the main, right? Where is the code initialized? See that it's probably multi-threaded because it's GUI based, and look for the handler that has the activate button, and look for the callback that initiates, the processing of your text. But that looks kind of complicated. So I, Googled and found a better way. And that better way is to use a program called Java Snoop. Java Snoop is a wonderful, wonderful tool, and it's a Java-based tool. Java Snoop. That essentially hooks into the Java virtual machine and is able to interact with other Java processes within the JVM. All right? So I'm going to start a new process. I find the jar file that is, the Java executable, and I start the process up. Process waits for a second to instantiate and then loads the GUI that lets me manage it. And say, okay, so I have this screen here that is the screen that manages Java Snoop, and I have the application under test here, the Defender soft token. So let's just try it and see what happens. just to make sure it's working. So I enter the token, and I click activate. Okay, activation code is invalid for this platform. Oh, by the way, Quest Defender decided to restrict the activation codes to only certain platforms. But I can worry about that later, so I'm okay. What I want to do, remember, is find out where in the code my activation code is being processed, because that's the code I want to modify. So they make a great thing called canary mode. Canary mode is a system that you input what you're looking for. I'm going to look for the letter E occurring 4 times. And everywhere that string, a string that contains 4 letter E's is processed, the Java Snoop is going to dump what function that is. Okay, so see how that works. We'll go demo and E. And if you can see that there, these are the functions. You know, first the system calls activate token, then it calls check token, then it calls DT check platform. That's probably checking for the platform, right? So Java versus Android versus iOS. Deserialize blob, and from printable string. So my guess is that the code that actually decodes that activation code is probably this from printable string. All right? Reasonable guess. Turned out to be right, which is probably why I'm now claiming it was reasonable. And I didn't have to read and follow the code, right? I used a tool to tell me where to look. So that was very enjoyable. So we do that. So now we're back. And this is where we came to, right? So we know that from printable string, deserialize blob, DT check platform, check token, et cetera, et cetera. And we're going to work our way back up the stack, so to speak. So to do that, I'm going to use another tool that I searched for because I wanted to convert. So I went into to the code from my JAD file, and I copied out this section of code. And I'm trying my best to understand how does it work. How does it take these lowercase alphabet characters and turn it into something that means something to the token. I wanted to write a utility that would convert these for everybody to use, and I wanted to write it in JavaScript, mostly because JavaScript and HTML could make a reasonable GUI without much effort on my part, and it could be self-contained, right? I don't want to release code that uses a web service to receive your activation code and give you the QR code, right? That might be a poor security architecture decision. So I'm going to use a piece of software called Plunker, if I'm pronouncing it right. I hope so. And what Plunker is it's kind of like a little mini rapid prototyping engine, all right? So for making code that executes in JavaScript, right? So it has an index file. It's going to execute the code in this script. In this script, I've copied all of the code from the JAD file, and I've added a little, hello, just to make sure that this works. And I'll just click run. And of course, I learn that these things are not generally compatible, right? If I remove the comments from my Java code, this will not compile, all right? But what's great is, for someone who maybe is not a programmer, it's highlighting all the errors for me, right? And so I'm saying, well, okay, you're defining a private static string. I'm going to Google for how do you define strings, and I'm going to learn that JavaScript just uses the word var. And I'm generally correct because the GUI made the red X go away, right? This is natural compliance engineering. You get rid of the red X, right? So I'm private int, okay, it's actually a function, so I learned that is the word function. Still has problems because I learned that JavaScript doesn't cast varies or doesn't apply casts to values. So you have to get rid of things like string because it's going to figure out the type itself. And that goes away. So I go through the code, and then I'm probably going to do some stuff like this. Console.log J, right? I mean, I'm not a complicated individual. I use printf. as my debug, right? You could use GDB, or you could just use printf. So I go through the code, and I just keep running it until I get something that works. And eventually, I'll come to the realization of something like this. I'll just output everything. And you can see up at the top of the slide is the activation code, so you can follow along. On the right hand of the slide, I could see for the first loop, the character was the letter E. The index of whatever that is the number 4. The second character is the letter N. The index of is number 13. And then the value, whatever that is, 8 byte 0, is OX4D. That appears to me to be made up of the first value, 4, and the second value, 13, simply represented in hex. So I follow this along a little bit, and I'm able to discern the pattern. What is the algorithm here, right? The algorithm turns out to be relatively simple. You have letters A through Z that are numbered 0 through 25. That looks like a common, like Caesar cipher, right? You just have a letter, it's going to become a number. And then in kind of 2 blocks at a time, each value becomes, the high and low order bits of a byte, of a character, right? So 04D is made up of 4, which is the letter E, and 13, which is the letter N. And then the tricky part of those folks at Dell or Quest is every other pair, they add 10 to it. So all I have to do is subtract 10. So if I look at the letter Q, Q is 16, subtract 10 is 6, that becomes 6. W is 22, subtract 10 is 12, that becomes C. And then it repeats, A is 0, becomes 0 and 50, etc. So I'm able to now write some code that is a little more intelligible than just copying and pasting from Java into the system. And I have going up the stack. So we did this code. We did from printable string. And we were able to decode it. So we decoded the activation code. What is left to get at the contents of the system? Well, there is, unfortunately, some encryption, right? Set encryption key, get encrypt soft digest. I look at the code there, I look at the JAD files, and it's 400 lines of code. There's a lot of math. There's bit shifting. I mean, these are things, that I try to avoid, okay? And especially trying to go from Java to JavaScript with bit shifting and a lot of XOR and stuff, it wasn't a good recipe for me. So I'm like, there has to be a better way. So we'll just park that. And then there appears to be a couple loops. So there's one loop that has an install key and a des decrypt, okay? Then there's something that is a loop that XORs the value, okay? XOR is a common cryptography hiding thingy. And then it does it again. It makes a loop again. And then it makes a different XOR with a different value. So what I want to do is use JavaSnoop and another tool that I'll showcase called CyberChef. And I'm going to learn that a couple things. One, without even really having to learn, what do we think the encryption algorithm is? It's DES, right? Because they named it DES decrypt, right? And I don't think it meant that DES encrypt the data for you, right? So it's definitely DES. And it's interesting, it's 8 bytes at a time, because you can see in the for loop, it's plus 8. It's I equals I plus 8, right? And that tells me you're going 8 bytes at a time. And how am I going to figure out the key? I'm going to figure out the key using JavaSnoop. So in order to do that, I have to use another capability in JavaSnoop called adding hooks. So I'm going to browse for the functions. Okay, and I'm browsing for the des function. Oh, there we go. Hold on here. There we go. And I see that there's install key, so I'm going to add a hook for install key. I'm going to add another hook. Des. And the other hook was des decrypt, right? For des decrypt, okay. Hooks are capabilities in JavaSnoop that let you tamper with the parameters or tamper with the return value. There's no return value, so it's not letting me tamper with it. I don't really care to tamper with the value, but I want to learn what those values are. Because I know, from, I think this is now common knowledge, right? To encrypt and decrypt something, you need ciphertext, the part that's encrypted. You need a key, and you need an algorithm. So I think install key might be the key, just a wild guess. And the decrypt function is going to have that information in it. So let's go ahead and enter an activation code and see what happens. All right, so we'll go demo 9, activate. Great. So I'm at my first install key. So what do? I edit it, and I copy this value. I am just, essentially opening a notebook. Where is it? There we go. There we go. Essentially opening a notebook and saying install key is this value. Okay? And I've gone ahead and kind of done a lot of this. It's like Betty Crocker, right? You never see her make the whole cake. She puts it in the oven and it just magically comes out. So I copy the install key, all right, and I go back to JavaSnoop. Great. Okay. Now I'm on DesDecrypt, and I see some more values. Okay. So I copy those values over to Text Wrangler, and I can see those are my values. What's interesting is already I can see some commonalities. This is my decoded key, and this is the text. These are the bytes that are being sent to the DesDecrypt. So it's clearly what's happening is DesDecrypt is going to decrypt the ciphertext that I decoded. It's also a nice win because it validates that we were doing the decode function properly. Okay, so I accept the changes, go through again. I look at the next install key, I copy that, I paste it down here. Don't know that is there anything interesting here? There kind of is. Hey, look, some bytes of the install key are now the first set of bytes of my decoded key. That is very interesting. So I'll copy the DesDecrypt function value, and then I'll do that like 1 or 2 more times. I'm always trying to just figure out, I'd say a higher order function. What is the system doing? How is it doing it? Well, in order to figure that out, I've got some data now. I have install key values, I have ciphertext values, and look at this. The second time I called DesDecrypt, the first 8 bytes are no longer the 8 bytes of my decoded value. This suggests to me that this might be the decrypted value. So if I can get some kind of program to take the key, to take the ciphertext and produce this output, I think I'll be well on my way to figuring out how this works. So in order to do that, I'm going to use CyberChef. CyberChef is a fantastic product. It's free, and what's really great about it is it lets you, rapidly prototype modifications of data, right? So I could do this. I could say I want to take something to base 64, and then I want to make a hex dump to hex dump, and then if I type this in, it gives me the hex dump, right? And they call it recipes because you're a cyber chef. This tool is just awesome. It's open source and published, okay? And they have, which is great because I did not care to write an encryption and decryption function. They have DesDecrypt. So they have the decryption function for me. I don't need Python. I don't need, and if I code something up myself, I'm almost always confident that I made a mistake. So if it doesn't work, I don't know if it didn't work because I'm a horrible programmer, which is a truism, or if I'm misunderstanding something. So as much as possible, I try to rely on other people's code to validate. Sometimes they're wrong, though, which I did learn. So let's go back to round 0. Install key is this value, okay? So the key goes here, and it's in hex format. That's super easy. I don't have to do much. We'll just stuff something in there. And the input is the ciphertext, right? And what I'm going to do is I'm going to say, look, I'm only going to input the first 8 bytes because only the 8 bytes changed, right? Why make more work for myself? It's, I just want to be simpler. So I'm going to take the first 8 bytes as ciphertext. And 1, 2, 3, 4, 5, 6, 7, 8. Yep, So now there's a lot of variables and configurations for DES decryption, as simple as it is. So I might play with some of these values and say, hey, okay, if it's CBC mode, it's definitely not that padding. That's not getting me a result. Oh, that's okay. So that didn't go very well. Also, I want the output to be hex. Okay, so I did get some value there. And remember, the value I'm looking for is 4107. So if you see 4107, let's stop. Okay, so I'm going to say, okay, let's find, cipher block chaining. I think that's cipher feedback mode. I'm not getting my code. Counter mode, not getting a code. Output feedback block cipher, maybe not working. ECB, none of these things are working. Okay, that would normally be bad for the demo, but I've expected and anticipated this. All right, so what could some of the issues be? Well, if I look at my key is actually 16 bytes. DES, quick Google search, is how many bits of strength? 56. But they technically use 64-bit keys, and there's just sloppiness that drops it to 56. So I only need 8 bytes. So the question is what 8 bytes make up the key? Well, I know if I go to the end of the file and I remove data, my output doesn't change. It doesn't change because only the first 8 bytes are being used. So I know that the information is not in the first 8 bytes, or it would have already given me an answer. So what I'm going to do is just delete 2 bytes at a time. You'll see my output change, okay, but I'm not getting the code I want. So I just keep, holy shit, right? So it's good, because now, that was a good pause, that was for dramatic effect, right? Because now I have, with the key, and what turns out to be the last 8 bytes of the install key variable, I now have this input that generates F1079F83DAC6. So I have successfully recreated in other code the decryption algorithm. That's really cool, all right? It was a good day when that happened. So we can repeat those steps, but in the interest of time, I won't. But we could XOR, right? So the other thing is we could make sure, is this really working or not? So they have an XOR function, right? And the XOR function goes, what's the value? AA, right? Okay. And of course, the output is hex, so I have to go from hex, which makes binary data. I XOR the function, and then I go to hex. And now this would be the first 8 bytes through the install key DES decrypt loop and the next XOR. And then I repeat this for the next install key loop, and it turns out they use a different algorithm, not a different algorithm, but they get the first 8 bytes a little differently. But it doesn't matter because my approach still works. And now what I'm left with is the decoded activation code, the ciphertext. We know what it is because we decoded it. The key is very simple. The key is that blob, that first 8-byte blob, plus the rest of my activation code. So they're using the activation code to kind of decrypt itself, just slid over 8 bytes, right? Which, if you think about it, maybe that was the only option they had because they had no network connectivity. They couldn't exchange keys, et cetera. The code has to work on every platform. So that is what they have. And then this is the DES decrypted plaintext. If I repeat these steps, I now have, in that long text, in those long hexadecimal values, that is the completely decoded activation code. That's fantastic, but it doesn't really help me enough yet. What I'm looking for is, remember I said the token serial number is probably in there, and there has to be data to generate the HMAC one-time password. Where is the token serial number? Well, I know that the token serial number is 3053 whatever, but my activation code, when decoded, when decrypted, it's not in decimal. So I just use Google to say, what is this number in hex? And I get this value, Baker 6, 02, 3 David, 04. Do you see that value anywhere in here? Yes and no. You see it, but it is endian. I just say it's endianed because I always get my big or little mixed up, so I just abstract it to say there's an endianness about the data, which is the case. And I can see the second to last 4 bytes appear to be where the serial number is, okay? So it's great because all throughout this exercise, I'm getting like a positive feedback loop from the research telling me I'm probably on the right path because the serial number was there. The last byte, 82, is probably just an integrity check or checksum. That just seems something that programmers can't help themselves from doing. Okay? So I want to take this now and figure out where is the secret data that generates the SHA-1 HMAC one-time password. So to do that, let's just take one little sidestep and do a little further Google research into HOTP, right? I mentioned it was this RFC standard. It has components that are shared secret that generates that, and it's counter-based, right? The other common one-time password compliance system is TOTP, time-based. Time-based is technically the same as HOTP, except the counter, instead of being like 1, then 2, then 3, the counter is like the number of seconds since the epoch, divided by 30 or 60, all right? So the counter, it's still the same function, it's just how they calculate the counter. And then we want to make this work in Google Authenticator, so we have to do a little more to say, the base 32, the key has to be base 32 encoded, all right, that's good to know. And the C is the incrementing counter, that's just a number. And truncate, Google Authenticator, while completely compliant with the standard, actually only supports the 6-digit version of these codes. So that's just stuff I need to be aware of. So now I want to say, how can I generate these tokens, right? So my goal is to figure out, I've got this amount of data, these are the bytes, somewhere in here must obviously be my token, right? The data that generates the one-time password. I don't know where it is, so I grab a very quick Python script. I actually made the Python script minus the imports, and I basically say, I'm going to go through, starting at byte position 0 and for 1 byte, all the way through the end, through all the bytes. I'm just going to calculate one-time passwords over and over and over again, make the first 5 OTP calculations, and save them to a file, and then when I grep for my token and I find the X and Y values, I'll know positively the start and stop of the secret. Fantastic. It would have been better if it had worked, okay? So that didn't work, all right, which happens, from time to time, all right? And so that we have to throw away. I also tried endianness, right? So I tried just, the serial number was endian decoded, right? So it would make sense, that they might do that too. So there's a script in there where you might say I calculated the endianness, but literally I just wrote the hex bytes backwards. It had the same effect, right? And that didn't work either. So now, remember, I can go up the stack and I can figure out actually what is the secret, right? I'm using Java Snoop. So why the heck don't I snoop it and figure out what the actual bytes are and compare it to my decoded value? All right, so let's go ahead and do that. So I'm back into Java Snoop land. All right, accept all the changes. All right, so now I'm at a problem. Through my Google searching and finding freely available activation codes for research, did not find an activation code that worked for the Java client. So I don't get the ability to generate the one-time password. But I have complete control of the application, so I might have an in, right? So what I'll do is, if I go up the stack, if you remember here, right, so we'll do this. There's this, what does it do? Activate token calls check token. Check token is a Boolean. I didn't even have to Google what Boolean meant, okay? It's true or false. So my guess is if it's false, it didn't check out. So I'm going to modify that and see if I get some joy. All right, so I'm going to add a new hook. I'm going to look for, I'm going to browse, DTSDK. This is where it is. Browse, DT SDK. And I'm looking for, it was check token, right? Did I miss it? Check platform. Well, I don't think that's the same one. Well, yeah, it wasn't in DES, so that's a good one. Here, I'll tell you what we'll just do. We'll just, oh, actually, you know, if I was smart, I would just go here, look at the code. Oh, hold on, I'll go one over, and I got play. Get the nice visual effect. Okay, all right, I'll get there later. All right, so here, yeah, it's in quest.token, right? So I had the wrong class, all right? So easy mistake, anybody could have made it, I swear. All right, so we add a new hook, and I'm looking for, I already forgot, token, right? And it was, now I went and forgot it again. Quest.token? .java.token? Now see, see, I went too fast. Yeah, everybody, quest.token.java.token, all right? Quest.token.java.token, quest.token. Okay, yeah, so that's it, all right? And I've got, it's a Boolean I'm looking for. Boolean check token name, nice try, but that's not it. Boolean check token, okay? So add the hook. And this time, I want to only tamper with the return value. So, okay, very good. So I will do that. Enter my activation code, demo, Shazam, click activate, and the value is false. I am going to change this to be true. Now, in the interest of time, I'll save the 30 minutes it took me to figure this out. If I click true and click accept change, it won't work because the GUI wants you to like exit the cell. That was not a good day for me when that happened, okay? Because I thought I knew how programming worked, you know, even a little bit, and that didn't work. So, but now, Shazam, there's my token, 917622. I know, since I've generated a token, I've clearly generated a one-time passcode. So let's make another hook. Add another hook. Let's go for the word one-time password algorithm. And generate OTP, fantastic. And look, it even has a series of bytes and you know, some numbers. So I'm like, this is going to be a good day, I think. All right, so go here. We're going to tamper with the parameters. And I'm just going to refresh my token. And there are my values, 62, 2D, 74, et cetera, et cetera, et cetera, which turn out to be right here. All right, so I know exactly for this token what value was used to generate the OTP. And I'm able to lay that out, and now I'm able to figure it out, right? So I have, for whatever reason, they drop 3 bytes out of the stream, all right? And then the rest of the bytes, so it looks like, I think, maybe 20 or 40 bytes long. There looks to be some unused space that I at least didn't figure out. There's a platform type, so 7 is Android. We know where the serial number is, et cetera. So all I have to do is take this binary data, and if you trust me that this works, there's a base 32 encoder, and I just put that in there, and then I generate this one-time password, right? That is the secret URL that if I make a QR code, will generate OTPs that are compliant and synonymous with the Defender tokens. So let's see how that works in practice. We'll go to a demo. I used Plunker to build this system, right? So, and I learned a lot about CSS and divs and blah, 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 okay? Because previously my HTML was limited to GeoCities versions, right? Which was just H1, H2, maybe B for bold, all right? So we've stepped my game up considerably. And so I put in this Android code, I've got some fancy debug output, and I know that my token value is 917622, and I generate the Google Authenticator compliant token. That's awesome, okay? That's really, really good. I went ahead and made some other enhancements because as a counter-based token, this functionality is great when you get the token, when you get the activation code and you say, I don't want to use Dell Defender one time, blah, blah, blah. I want to use Google Auth because I use it for AWS and Lastpass and, I don't know, World of Warcraft. I use it for everything, so I don't want another piece of crappy software. So you got to figure out where is the token value. And every incrementing value, you can see the token value changes and the QR code changes. So if you know the token number, right, which is available in the view token information, you can get that. But you could also be really smart and say, if I know what a token is, if I enter that, I'll know that that is counter value 537. So I provide in this utility a way for you to enter your current token on the Defender app, enter the activation code, and I'll generate for you the QR code that Google Auth will map to an activation code that you can use inside Google Auth, and you can throw away the poor usable Defender token, which is fantastic. A couple gotchas about that, right, is that you have to be careful. You can't start using two tokens at the same time, right? Why is that? Anybody?
Because the counter will up on the bottom, so
right, exactly. The counter will go bad on you, right? And you'll see this in my lessons learned. I had the pleasure of doing that to myself because I was refreshing too many times, and I became out of sync with the server, and I had to ask for another activation token, and maybe there were some questions around what I was doing. So, you know, generally you want to avoid that, okay? So that was the demo, and it worked. So now a couple takeaways. You're looking at, because I think I was serious when I think not enough people, you know, showcase the steps they took to get where they are. This is a word cloud of all of my Google searches that led me through the exercise today. I put on Twitter this morning like a short video of the actual searches I looked for, right? And I would say it's humbling, right, to see a grown man claim that he had to Google for what is 13 in hex, all right? But this is how we make improvement, all right? So, you know, how do you write a for loop in Python? Every time I write a for loop in Python, I have to Google how to do it. So whatever, all right? Good security requires good usability. I would say it as information security professionals. We have got to stop making people go through the 9 gates of hell to authenticate to VPN, all right? It's not right, and you know, security has to be easy to use to be secure, all right? Get out of this, you know, we need you to hop and dance. In some ways, the takeaway was this was easier than it should be. There was no code obfuscation, all right? There were plenty of sample tokens to play with, right? Google image search for vendor activation code, and I got enough tokens to play with. I didn't actually code a whole lot of this stuff up. The DES function, the OTP function, the QR code generating function, even the CSS file came from the World Wide Web, right? So it's very easy for me to make this work. And in some ways, in honesty, I made this harder for myself, right? So I used old tool sets that I was familiar with at the time. JAD is like your father's decompiler, okay? Because there's JADX now, and it has a GUI. It lets you see all the code at once. It does a much better job. I talked about the token drift. Even CyberChef is being constantly maintained. So, organize, plan up front would be good. There's always a security trade-off, right? A lot of people use the time-based tokens because your phone is NTP aware because the telephone network requires it. The backend server is correctly timed because they require it. So it's very easy to use time-based tokens. And you say, only a fool would use a hardware counter. Well, maybe, but you got to understand is if you steal a time-based token, the victim never has the opportunity to learn that. If you steal a counter-based token, they may cause the drift. So there is a plus and minus to different token types. And I think the last takeaway is activation codes are secrets, and they must be treated as such. Just because Quest Defender says it's only good in Android, and it's only good in our app, and it can't be used anywhere, you might have a researcher who's upset about your poor usability and discovers that's not the case. So maybe you shouldn't email activation codes to all your employees because then a breach of the email system now breaches the multi-factor auth. Last note I want to make is about reverse engineering. because we did kind of peel away and look inside of something. And I highly recommend, I'm a big-time supporter of the Electronic Frontier Foundation. And they have a great website and a great article about reverse engineering. And they also can make available legal advice. And I had a great experience with them in this regard. So I encourage everybody, before you go taking something apart, you may want to understand what your risks and liabilities are. And that's it. And this is on GitHub. So it's my first GitHub public repo where they wasn't trying to fix somebody else. And it's called OpenFender, which was probably a better, cooler sounding name for the topic. And any questions? Oh, I'm sorry, I should have looked. Yes.
I didn't. Back when you were doing the key stuff,
Yes.
I saw there was a field for initial vector for the test key. I didn't see where you start that from. Was it there somewhere?
That's a great question. So the question was, just for the camera, was when I was doing the demo, there wasn't actually any reference to the initialization vector. I believe that there is actually no initialization vector. It's just in CyberCHF, if that value does not exist, you get a different result than any value. So I could have put the letter Q in and I would have got the right token. So don't really know, why, but my belief is there's not an IV in the decrypt function. It was an artifact I had to inject into a nuance of CyberCHF to make it work. Great question and good pickup.
Can you go back to that other slide?
Yes. Great. Any other questions? Will you all, oh yes.
So this is open source on GitHub now. Is Dell aware of this at this point, or do they have anything to say about it, or?
I have no idea. They're entirely welcome to run a Google alert for their own company name, and we'll find out. Hence the conversation with other people. But great, also good question. I don't know what their response will be. We'll find out.
We had a talk on that too.
Yep, very good. All righty, you all were a kind and gracious audience to host me. Thank you so much. I hope it comes across that I love this stuff, and if anybody wanted to work on stuff together, I would be more than happy to do so. And thank you all for your support. So, cheers.